On number 11, we have these two people, and did they do the problem right? Well, let's start with Mark. Mark, it looks like he wrote it in point-slope form. So y minus 4 equals negative 5, which is our slope, times x minus a negative 2. Well, you subtract a negative 2, you get x plus 2. You get negative 5x minus 10. And then it looks like he added 4 to both sides. You get negative 6, so y equals negative 5x minus 6. Well, notice Josephine has the same answer as Mark did, except Mark took it out another step. So yeah, they're both correct. Mark converted to slope-intercept. Josephine left it in point-slope form, and there's nothing wrong with that. Number 12. And this kind of leads to number 11, and number 10 kind of leads to number 12. When is it easier to use point-slope form, and when is it easier to use slope-intercept form? Well, it's easier to use slope-intercept form if you know the slope and the y-intercept, or at least you know the y-intercept, and then you can find the slope. Otherwise, if you're given 2 points, or if you're given a slope and a point on the line, it's easy to use point-slope form. So point-slope form we actually tend to use more often because it's easy to work with, to write. But slope-intercept form is easier to understand, so sometimes we leave it like that. So here's a perfect example. Write an equation in slope-intercept form. So this one I told you the answer. So we're going to kind of do this like Mark did. And I want to be parallel to the line y equals negative x plus 11. So for I know the slope of my line is negative 1. So the parallel slope is negative 1. So I'm going to start this problem by writing it in point-slope form. So I'm going to say y minus 5 equals negative 1 times x minus a negative 3. So I'll write that as y minus 5 equals negative 1 times x plus 3. Distribute that negative 1 inside. Y minus 5 equals negative x minus 3. Then to get in slope-intercept form, we just add 5 to both sides. Y equals negative x plus 2. And that choice is C on this one.